last class we did chemical kinetics, that is rate of chemical reaction, and then we said the rate of chemical reaction talks about the speed of the chemical reaction. That is how fast or how slow the chemical reaction is. And we said based on that, we have very slow reaction, very fast reactions, and moderate reactions. So we said very fast reaction, they are very instantaneous, they occur within seconds, while moderate reactions may take minutes or hours to occur, while very slow reaction may take up to a year or years before they can occur. I will give an example. Then we listed some factors that affect the rate of chemical reaction. So let me select 7 people now. So each person will tell us each of the factors and how they can affect the rate of a chemical reaction. Are you ready? So I'm selecting 7 people now.
Yes, sir.
So you tell us the factors that affect the rate of a chemical reaction and how they affect rates. Augustine, Elijah, are you there? Augustine, Elijah, are you there? Okay, if you know the answer, just raise your hand. I will just pick randomly. You know you can answer, raise your hand. Let's see. Israelogy, I'm not calling you. Others can raise our hand. Okay, Blessing. So can you give us temperature? How does temperature reaction?
Increase in temperature in a reaction increases rate of reaction, thereby stimulating the catalyst.
You are missing them up. When you increase temperature, what happens to the particles?
If you collide with your
Increase it.
You collide more as a result of what? Like, so one word, I mean,
increase
you like the one word now too.
Increase the
Yes.
kinetic energy.
When you increase, that's what I want to hear. That's it. When the temperature is increased, the particles they gain more kinetic energy, and that's why they collide more, because they now move faster. So their collision will increase. Thank you. That's Blessing, right? Can you give us one?
So let me answer one now. If they answer my own, you go pay me.
You have 7 now. I can't do the bonus, so can you tell us?
Yes, sir. Increase in pressure.
Okay, how does increase in pressure? How does it affect the rate of
It increases their collision, especially in gases.
Increase. Let me help you. It increases the frequency of collision. Okay, the pressure increases the frequency of collision. Okay, thank you. Let me say this. For gases, we talk about pressure, right? But we can also talk about volume. From Boyle's law, we know that volume is inversely proportional to pressure. So if increase in pressure, we increase the frequency of collision, increasing the rate of reaction. A decrease in volume will increase the frequency of collision for gases now, because when you increase the pressure of gases, the volume will decrease, and when you decrease the volume, the pressure will increase. So increasing the pressure of gases or decreasing the volume of gases, you are increasing pressure.
What you said. You said if you decrease the volume, what happens?
And when you increase pressure,
following the law of Boyle's law.
Increasing pressure is the same thing as decreasing volume for gases, based on Boyle's law. Remember, volume is inversely proportional to pressure. So when you increase the pressure, the volume decreases, so the rate of the reaction will increase. Can we get that? Now let's take some questions on that before we move to our next topic. Just pick some questions randomly here. Okay, we have question number 1. Can we see that? Can we see question 1?
No, sir. I'm not saying anything.
Yes, sir.
Maybe it's the network. Can we see question now? The question says,
Okay, I can see it, sir.
which of the consider the reaction H2 plus I2 equals to giving us 2HI. Which of the following will decrease the number of effective positions of molecules of the reactor? So they're asking for the one that will decrease the number of positions. So indirectly, the one that will decrease the rate of reaction. So number one, A, if we increase the pressure, what will happen to the rate of reaction?
It will increase.
It will increase.
So that means A will not be the answer, right? When you number two, rise in temperature. When the temperature increases, what happens to the rate of the reaction?
It will
It increases.
Yes, sir.
It will increase too, right? So which means B is true. When you increase the volume of the reaction vessel, when you increase volume, increasing volume means you are doing what to the pressure?
Decrease.
It means you are decreasing the pressure. So if you decrease pressure, what will happen to the rate of reaction?
To increase.
When you increasing volume is decreasing pressure. So when you decrease pressure, it will decrease the rate of the reaction. So which means that is our answer, right? Remember, when you introduce a catalyst, it's going to increase the rate of reaction. So what's our answer now?
Option C.
That is
C,
right.
that's increasing the volume.
Okay, good, thank you. Number two says, which of the following factors will slow down? Will slow down. That means that will decrease the rate of the reaction. Number one, exposure of the reaction vessel to sunlight. Number two, addition of distilled water to the reaction vessel. 3, increasing temperature. D, presence of MnO2. So the first one says exposure of the reaction vessel to sunlight. This is the composition of hydrogen peroxide. The composition of hydrogen peroxide is also a photochemical reaction. I gave us some examples of photochemical reaction the other time. We said conversion of silver halide to silver metal in photographic film. We talk about photosynthesis. We talk about reaction between hydrogen and fluorine in light, and needs presence of light. Also, I told us that we have a lot. So one of them is also the composition of hydrogen peroxide. So the composition of hydrogen peroxide is a photochemical reaction. So when you expose it to sunlight, the rate of the reaction will increase. So that will not, we are looking for the one that will slow down the reaction. That is the one that will decrease the rate of the reaction. So A is light. In the presence of light, the reaction will be faster. It's a photochemical reaction. B says addition of distilled water.
Yes, sir.
When you add distilled water, that means you are decreasing the concentration. You are decreasing the concentration. So that means you are diluting it. I think I will do some questions on that. When you dilute a solution, it will reduce the concentration of the reacting particles. So the reaction will be slower. So when you decrease concentration, reaction is slower. When you increase concentration, reaction is faster. So because you are distilling the solution, the reaction will be slower. So that is the decrease in the concentration. Then C, increasing temperature. Remember, when you increase temperature, the rate of the reaction will increase. So C, increasing temperature will increase the rate of the reaction. Then D, presence of manganese oxide. Manganese oxide is a catalyst. Catalyst will increase the rate of the reaction. So the only one that will decrease the rate of the reaction then, according to the equation, will be addition of distilled water, which will dilute the solution. So diluting the solution will decrease the concentration of the reacting particles, so the reaction will be slower. So dilution will decrease the rate of the reaction. So our answer there will be what now?
B.
B.
B, sir.
Do you get that?
B. B.
Now,
Yes, sir.
3 now says, verse 3. In the chemical reaction above, the substance that will increase the rate of chemical reaction. This is Haber process. In the Haber process, the catalyst used is finely divided iron. Finely divided iron is the catalyst in the Haber process. So we use finely divided iron as catalyst in Haber process. Platinum is used as catalyst in hydrogenation of oil, production of margarine. You can use platinum or palladium. Vanadium 2 oxide, 5 oxide, that is V2O5, is the catalyst in contact process. That is production of H2SO4. Finely divided catalyst can be used as catalyst in some organic reactions, maybe like dehydrogenation. So we'll talk about all this later, because we still look into catalysts under chemical equilibrium. So we still look into catalyst. So in the Haber process, production of ammonia, the catalyst used is finely divided iron. So that's the catalyst used in the production of ammonia. I believe you get that. So all the
Yes,
four
sir.
substances they are catalysts. The one that is used in the Haber process is iron. Do you get that? Number 6. Number 6 says the activation energy of a reaction can be reduced by what? The last time we talked about activation energy too. I would say activation energy refers to the minimum energy required for a chemical reaction to occur. So if a chemical reaction will occur, the minimum energy required by the reacting particles is the activation energy. And the only way the activation energy can be lowered is by using catalyst. Addition of catalyst lowers the rate of chemical reaction. Remember, for option A, increasing the reaction temperature. Temperature will increase the kinetic energy of the reacting particles, so it makes them more energetic. Increasing temperature will make the reacting particles more energetic. Then B, increasing the surface area. Increasing the surface area will increase the number of contacts, not the activation energy. Increasing the concentration, that means you're having more of the reactive particles. That is increasing the concentration. And when you introduce a catalyst, a catalyst lowers the activation energy. Do we get that? I can see some people raising their hands. Okay. What are the questions? Let me start history.
Now, what's the answer to number 3? So what's the answer to number 3?
3. I will say D. Finely divided iron. We use finely divided iron as production of as Haber process. We use that. Do we get it?
Yes,
Do we
sir.
get
Yes,
it?
sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Equal Jeremiah, you are raising your hand. Okay. Now let's move to the next one now. I was talking about this graph. That is part of what we are doing today. Now, question number 8. We have the rate curve here. And remember the properties of the rate curve. At the beginning, the reaction is fastest. As reaction proceeds, it slows down. Then the line becomes horizontal to show the end of the reaction. Question here says from the graph above. I'm reading question number 8 now. From the graph above, it can be deduced that the production of gas stopped after. So afterwards, that is from the point where the graph becomes horizontal. So the graph becomes horizontal at what?
15 minutes.
So that means the reaction stops after. Do we get that? We have question number 9. You have rate curve. The rate curve number 9 represents the reaction between a fixed mass of K2CO3 and a 0.2 molars DM cube solution of 2 acid E and F. Which of the following statements about E and F is false? The one that is false. A says the volume of gas evolved is the same for E and F. The volume of gas evolved is the same for E and F. Is that true?
No, sir.
No,
It's
sir.
not. No.
Okay, that is true. Because they meet here. You know, at the end of the reaction, when the reaction stops, the volume will not change again. So it's only that the time at which the reaction stops differs. The reaction for the production of E stops before the reaction for the production of F. I don't know if you get what I'm trying to say. Now let me try to make questions. Our E is like this. Then F is like this. So for E, now the reaction for E stops here. You see that's where the line became horizontal. So let's say this is 5. Then that of F stops here. So let's say maybe 20 minutes. So at the end of the reaction, they both meet here. So they both produce the same volume. The same volume is produced. Only that for E attains completion. The production of E attains completion after 5 minutes. So, but it is still the same volume. If you keep the solution, the volume of E will not change again as the time increases. So the volume of E will remain the same. Do we get that? Assuming the curve do not meet, then their volume will be different. The only difference here is that the reaction that produces E is faster than the reaction that produces F, but they have the same volume at the end of the reaction. So the reaction that produces E is faster than the reaction that produces F, because the production of E comes to completion after about 5 minutes. The time comes first. So I just use 5 for example. Then for F, the production of E comes to a stop at the end of about 20 minutes. So the volume of the gas produced that is at the end of the reaction. But at any point before the volume, do we get that? So A is correct. Now let's check the other option. Option B says F is. What is it?
I wanted to ask the question under surface area before we proceed, sir. Hello, can you hear me, sir?
I can hear you.
Yeah. So one of the textbooks I was going through, I was seeing something like lump gram powder. I don't know how it is related to surface area. If you can explain, sir.
I still love Jonathan. I just love just like your man. I love magic cube or sugar. Then when you grind
Yes.
it, you have the powder.